So example 8. So suppose the sine of alpha is equal to 4/5 for a quadrant 2 angle alpha, and sine of beta is equal to 1/2 for a quadrant 1 angle beta. Find the exact value of each of the following. Alright, so now they're telling us that sine of alpha is this and sine of beta is that, but we don't know what the angles actually are to be able to find what sine and cosine of the other one is, okay? So they give us a place here we can make a sketch, so let's try this. So it tells us the sine of alpha is 4/5 and it's a quadrant 2 angle. So I know that sine is, I can look at it two ways. It's y over r, or we can look at it as its opposite over the hypotenuse. Okay, so if I draw in a quadrant 2 angle here, okay, and I'm going to erase that little line so you can see my angle there, and I make it into a triangle, that means the y value up and down, the opposite of my little reference angle right there is going to be a 4. My hypotenuse is 5. How can we find this side here? Well, we can use the fact that we know that x squared plus y squared equals r squared, or a squared plus b squared equals c squared, whichever. So let's see, we're looking for x. We know that y is 4, and we know r is 5. And hopefully some of you are like, oh, well, we know what it is because we know what kind of a triangle it is. But I would subtract my 16 and take the square root. And so x is equal to plus or minus 3. But now we're in quadrant 2, so what do we know about x? X is going to equal negative 3. Alright, then it tells me that, let me change colors here, it told me that sine of beta is equal to 1/2, and it's a quadrant 1 angle. So I got a quadrant 1 angle here, right there. Okay, so I made it into a triangle. And it told me the sine of beta is 1 over 2. So we know the sine is y over r. So y is our up and down, r is always our slant, or we could say it's opposite over hypotenuse. But we also need our x value there, okay? So I'm going to use the same thing, that x squared plus y squared equals r squared. We don't know the x. We know y is 1, and we know r is 2. So we get x squared plus 1 equals 4. Move the 1 over, so x squared equals 3. Take the square root, and x is equal to plus or minus the square root of 3. But we're in quadrant 1, and what do we know about x? X is positive. So x right there is going to be the positive square root of 3. Alright, so I'm going to label this. This is beta. And this angle over here was alpha. Alright, so let's look at A. A asked me for cosine of alpha. Well, cosine of alpha, so find your alpha triangle. Remember, cosine is either x over r, or you could say it's adjacent over hypotenuse, whichever way you want to look at it. But when you do, you end up with your x values, the way I'm going to look at it, is negative 3 over r, which was 5. So there's cosine of alpha. What about cosine of beta? Well, again, cosine is x over r. That's the way I'm going to look at it. So when I look at beta, my x value was that square root of 3, and my r value is 2, so there's cosine of beta. Now, why would they want us to find those? Because when we do C and D, we're going to need those values. So instead of going and having to find them at that time, they went ahead and let us find them ahead of time. So look at C. C says we're going to take cosine of alpha plus beta. Well, we know our formula. Cosine of alpha times cosine of beta minus sine of alpha times sine of beta. Now, we know cosine of alpha. Okay, cosine of alpha is what we found in A, which was equal to negative 3/5. When you do this, guys, cosine of alpha is completely replaced with the negative 3/5. Not just alpha, the whole thing, okay? No cosine. Cosine of beta. Well, we found that in B over here. Cosine of beta was the square root of 3 over 2. minus sine of alpha. Well, I can go up to what was given, and they told me there the sine of alpha was 4/5 times sine of beta. That's also given up there at the top. It was equal to 1/2. And then just like what we did before, we're going to multiply these two. Negative times a positive is negative. On the top, I have 3 times the square root of 3. So 3 square root of 3 over 10 minus, on top, we got 4 over 5 times 2, which is 10. I'm going to combine those numerators over that common denominator. So I got negative 3 square root of 3 minus 4 all over 10. And that's our answer for cosine of alpha plus beta. Now, let's look at D. D wants sine of alpha plus beta. We're doing the same thing, just a different formula. So sine of alpha plus beta tells us sine of alpha, cosine of beta, plus cosine of alpha times sine of beta. Alright, sine of alpha was given. Nope, yes, sine of alpha was given. It's 4/5. Notice, no sine there, okay? It's a whole thing. Sine of alpha is equal to 4/5, so we switch the whole thing out for it. Cosine of beta, well, that's what we found up here in B. Cosine of beta was square root of 3 over 2. Plus cosine of alpha, that's what we found over here in A. So negative 3/5. Times sine of beta, that's what was given up here at the top. So positive 1/2. And then we're just going to simplify it by multiplying. So we got 4 square root of 3 over 10. Plus, we have a negative 3 over 10. So when we combine them, we get 4 square roots of 3 plus a negative is a minus. So minus 3 all over the common denominator of 10. And so there is our sine of alpha plus beta.